So am I audible? Yes, please. Am I audible?
Yes, ma'am, you're audible, ma'am.
So am I audible?
Yes, ma'am.
Ma'am.
Okay. So yesterday we started with the different process, and today I told that I will be starting with the reversible adiabatic process for and the relation between PVT. See, it's a for reversible adiabatic process. It's not for the irreversible. So whatever formulas I am deriving here, you can't use those formulas for irreversible process. Okay? Delta U is equals to Q plus W. This is according to the first law of the thermodynamics. So for adiabatic process, Q is equal to 0. We all know this. So delta U is equals to 0 plus W, or we can say delta U is equal to W, but we write this W as adiabatic. Right. Now, in yesterday's class, we know that delta U is what? In CVM delta T. And what is this W adiabatic? Minus P external delta V. Now remember, try to remember that for an adiabatic, that for a reversible process, just for this term, that for a reversible process, P external is very much equivalent to P internal, right? P external is equivalent to P internal, and what we can say that we use integration. Okay, so up to this, is this part clear? For the reversible process, that means for the sand thing, P external becomes equal to P internal, and we use the integration sign. Do you remember this thing? Like it was long back, which I taught you in the class. Yes or no? Did you remember? Or
No, ma'am.
of course you won't. See, where is this? This is the reason I tell you to revise. So where was the sum? We have done long back for the reversible system. Okay. See, for any kind of reversible system, P external is equivalent to P internal, and we use this integration sign. Now, did you remember?
Yes, ma'am.
Okay. So try to remember this, because if I do this, it's just a waste of time. See, it's just a waste of time. Now I have to remove to that part again and just start solving the sums for you. Okay, so now how we can write this? So in the next step, we can write like N CVM delta T is equals to minus P internal of dV. Okay, so the same equation in CVM dt is equivalent to minus nRT by V into dV. See, PV is equals to nRT. So only P will be equivalent to nRT by V. So that is the thing I have written here. Okay. So this n and this n gets cancelled out. So what it is remaining, CVM dt is equivalent to minus of, if I just take the RT here, then dV by V. Is this part clear up to this? Up to this, is this part clear?
Yes, ma'am.
Okay. Now, have you understood why I have written delta U as this? Yesterday's class, we derived this formula. Right?
Yes, ma'am.
Okay. So, what can we write like this? CVM is a constant, remember, by R, integration of dt by t. So, it will be T1 to T2 is equivalent to minus of integration of V1 by V2 dV by V. So, CVM by R ln T2 by T1 is equal to minus ln V2 by V1. How can we write like this? CVM by R ln of T2 minus ln of T1 is equal to minus ln of V2 by V1. So again, we can write like CVM by R, which is ln T2 by T1 is equivalent to minus of ln V2 by V1. Now, if we just reverse this, then this minus sign will disappear, like ln V1 by V2. Up to this clear? Okay. So, what can we write here? See. Okay, I'm doing it in the next page only. See, formula for, up to this it is clear, right? Log
Yes, ma'am.
of a to the power b is equal to b log a. So far what we have got? We have got CVM by R into ln T2 by T1 is equal to ln V1 by V2. Right? This is what we have got. So we can write, this is what we have. So I can just write ln T2 by T1 to the power CVM by R is equal to like this. Can we write like this? ln T2 by T1 to the power CVM by R is equal to ln V1 by V2. Can we write like this? From this
Yes,
is
ma'am.
what is given. I have just written it in this form. Okay. Now, just this ln will disappear. So what we will get T2 by T1 CVM by R is equal to V1 by V2. So if I write like this, now again, what is this CVM by R? From the Mayer's ratio, what we know, CPM minus CVM is equal to R. If I divide both sides by CVM divided by CVM minus CVM by CVM is equals to 1, R divided by CVM, right? So this is what, this whole thing is the gamma. Gamma minus 1 is equals to R by CVM. So if I write CVM by R, that will be equivalent to 1 by gamma minus 1. So T2 by T1 to the power 1 by gamma minus 1 is equivalent to V1 by V2. See, this is a constant, right? This is a constant, right? And T2 by T1 is equivalent to something V1 by V2. So they are inversely related. So from this equation, can we write TV to the power gamma minus 1 is equivalent to constant. Okay, so this is a very important formula that you need to remember. So is this formula clear? How we are deriving it?
Ma'am, I don't get at the last point.
See, T2 by T1 is equivalent to something into V1 by V2. So T and V are inversely related. That you can understand though.
Yes, ma'am.
So I have just taken V here. If I take V here, obviously this will reverse. Okay. Or if I take T here, this power will just reverse. That's what I have done. Okay. Up to this, is this part clear?
Yes, ma'am.
Okay, this derivation is not important. Derivation will come for your boards. But in your NEET, you have to remember this part, this formula. Okay, now let's move to the second part. What is the second part? What we know, T v to the power gamma minus 1 is equivalent to constant. This is something we have derived just now. Now, PV is equivalent to nRT, ideal gas equation. Okay, so PV by nR is equivalent to T, right? Right or no? So, T v to the power gamma minus 1 is equivalent to constant. This is something we have proved just now. How we can write this T? T is PV by nR into the power V to the power gamma minus 1 is equal to constant, right? So what we can write? PV into V to the power gamma minus 1 is equivalent to nR into constant. nR is a constant, right? nR is a constant from birth. And what is
Yes.
constant multiplied by constant? It also becomes a constant.
Constant.
So what we can write this? P v to the power 1 plus gamma minus 1 is equal to constant. So P v to the power 1 gets cancelled. Gamma is equivalent to constant. So this is another formula that you got, that you have to remember. Is this part clear? This derivation?
Yes, ma'am.
Good. Okay. See, next one. Again, PV is equivalent to nRT. So what is V? V is nRT by P. Now, we just derive PV to the power gamma is equivalent to constant. So P into what is volume? nRT by P to the power gamma is equivalent to constant. Okay. So from this, what we can write? P into T to the power gamma by P to the power gamma, right, is equivalent to constant divided by nR to the power gamma. Can we write like this? This is a constant. So constant divided by constant, what we get? A constant. So how can we write like how this? P into 1 minus gamma T to the power gamma is equivalent to constant. So this comes your third formula. So is this formula derivation clear to you? This one?
Yes, ma'am.
Yes,
Okay.
ma'am.
So what can we write? For reversible adiabatic process, this is only for reversible, not irreversible. What are the three formulas? What are the three formulas? P v to the power gamma is equal to constant. T v to the power gamma minus 1 is equal to constant. And p to the power 1 minus gamma
Gamma.
to
T
t to
raised
the
to
power gamma is equivalent to constant.
constant.
Okay, these are the three formulas only for what? Reversible adiabatic process. Okay, see. Okay, now can we move to the next? See, during the work calculation, I have told you for adiabatic process, we will be calculating the work in separate manner. Did I tell you that for adiabatic process, we will be calculating work in a different manner? Okay, so work calculation in what? Adiabatic process. So what is the first case? Case 1. Case 1 is irreversible. Till now, what we are calculating? Till now, we have calculated the relations between P, V and T for reversible process. Now we are calculating work calculation for irreversible process. Okay, let's start. What is it? Delta U is equivalent to Q plus W. According to first law of the thermodynamics, Q is equivalent to 0 because it's an adiabatic process. So delta U is equivalent to W, but we write W like this. Okay, now what we can write delta U as N CVM dt or delta T, whatever you write. And what it is this? Minus P external delta V. Can we write like this?
Yes, ma'am.
Now, for irreversible process, what I told you that for irreversible process, wait, for irreversible process, there will be no integration and P external will not be equivalent to P internal. So, this we will simply write like P external V2 minus of V1 N CVM delta T. This is a very important formula. You can forget your name, but not this formula. Okay, this is an important formula. Now, I can use this formula and write like N CVM delta T is equivalent to minus P external. If I write it in the form of PV, NR T2 by P2 minus NR T1 by P1. Can we write like this? The formula
Yes, ma'am.
that PV is equals to nRT. So V becomes nRT by P. So V1 is nRT1 by P1. V2 is nRT2 by P2. So I have written the formula like this. So is this part clear? This is a very important formula. Very important formula. I don't think you will be getting this formula in your books. Okay, up to this clear?
Yes, ma'am.
Okay, now you know what they will ask you? They will just ask you that in your question you will get this work calculation in an adiabatic irreversible process. But in most of the cases, they will not give you this final temperature. You have to calculate this final temperature. Okay, if the final temperature and the initial temperature is already mentioned in your question, then for irreversible process, you can calculate the work by W is equals to NCV delta T. This formula. Okay, but if the final temperature, in most of the cases, final temperature is not given. So by using this formula, you have to first calculate the final temperature. Okay, or the initial temperature. Any one will not be given. So by using this formula first, you have to calculate this temperature. After you have got this temperature, then you can use this formula to calculate the work done. Did I make myself clear? Did I make myself clear?
Yes, ma'am.
Okay. So now if you ask me, just, so I'm moving to next slide, okay? Case 2. Case 2 is reversible. Now you can tell me that, ma'am, whether will in the reversible, the final temperatures will be given? Nope. Okay. The final temperature is given? No. The final temperature is not be given even for the reversible process. In your reversible process, we have derived 3 formulas, right? These 3 formulas we have derived. We will be using either of this formula to calculate this final temperature. Okay, either of these formulas to calculate this final temperature. Once the final temperature is calculated, then we will use this formula. Delta U is equivalent to Q plus W. Q is already equivalent to 0. So delta U is equivalent to W at AVT. But how we will use this formula? NCV delta T is equivalent to work. Once the final temperature is known, okay, by using either of those 3 formulas whose derivation we used, then we will use that formula to calculate this. I mean to say, if the final temperature or the initial temperature is not given, then to calculate this, we will write T v to the power gamma minus 1 is constant. Then P v to the power gamma is equal to constant. And then P to the power 1 minus gamma and T to the power gamma is equivalent to constant. Either of this, or either we will use this or this or this to calculate our final temperature. Once the temperature is known, then we will use this formula to calculate the work done. Is this part clear? Is this part clear?
Yes, ma'am.
Now, instead of doing this, now to calculate the final temperature, whether I will be using this or this or this, that will depend on the question. When we will be solving the questions, we will see. But till now, we will be using these formulas, then we will shift to this. But if the final temperature, initial temperature, everything is given, we will directly use this formula. Everyone say, is this part clear?
Yes, ma'am.
Okay. So now, for reversible process only, I can derive another formula for reversible process only. Okay, where will I write? For reversible process. Okay, I can derive another formula. How to derive that? See, PV to the power gamma is equivalent to constant. I am considering this constant as K. Okay. What is work done? W is equals to minus P external delta V. Okay. And I told you for reversible process, P external becomes equivalent to P internal and we use an integration sign. Right? We can do like this. Okay. If this is P, what we can write? P as K by V to the power gamma. So, K by V to the power gamma into dV. Volume 1 to volume 2. K is a constant. K will come out. 1 by V to the power gamma into dV. Okay. This is a formula. Okay. This has a formula. So, it is the minus K of integration of V1 by V2, V to the power minus gamma into dV. How can we write the formula? Okay, x to the power minus L into dx. This integration has formula of minus n x to the power minus n plus 1 divided by minus n plus 1. Okay, this has the formula like this. So how can we write this formula? Okay, see this very carefully. V to the power minus gamma plus 1 divided by minus gamma plus 1. V1 by V2. Okay, so we can write the derivation like this. From this line to this line. Okay, so minus K, it will be V2 to the power 1 minus gamma divided by 1 minus gamma minus V1 of 1 minus gamma to the power 1 minus gamma. I know this is looking quite a bit tough, but up to this, is this part clear?
Yes, ma'am.
So, up what can we write like this? K into, if I want to remove this minus sign, V1 1 minus gamma to the power 1 minus gamma minus V2 of 1 minus gamma to the power 1 minus gamma. Up to this, is this part clear? So, up to this clear, right, everyone?
Yes, ma'am.
Okay. So, what we got so far? We got like K into V1 to the power 1 minus gamma, 1 minus gamma, minus V2, 1 minus gamma by 1 minus gamma. Okay. What can we write this? Okay, if I remove this K, okay, if I remove this K, see, P v to the power gamma is equivalent to K. So P1 V1 to the power gamma is K and P2 V to the power gamma is equivalent to K. We can write like this. So it is K into eta minus K into this. So what we can write K as? K is P1 V1 to the power gamma into V to the power 1 minus gamma divided by 1 minus gamma into P2 V to the power gamma into V to the power 1 minus gamma divided by 1 minus gamma, right? Can we write like this? So, see, gamma will cancel out. So, it will be P1, it will be P1. It will be P1, V1, 1 minus gamma, P2, V2, 1 minus gamma. So it will be P1, V1 minus P2, V2 divided by 1 minus gamma. So it will be P2, V2 minus P1, V1 divided by gamma minus 1 from here to here. I'm writing. So what we were calculating? W reversible. So W reversible is P2 V2 minus P1 V1 divided by gamma minus 1. So it is delta PV divided by gamma minus 1. What is PV? NR delta T divided by gamma minus 1. So is this part clear?
Yes, ma'am.
So this is our another formula for adiabatic process. This is another formula to calculate work done for the adiabatic process. Up to this, is everything clear? Up to this, is everything clear?
Yes, ma'am.
Okay. Okay. So let's do one sum. A gas expands. This is your JE question. Adiabatically. At constant pressure. Such that T is directly proportional to V to the power minus half. Okay. Find gamma. How to solve? T V to the power. See, in your question, constant pressure is given. I have told you repeatedly, constant pressure means what process?
Reversible.
Yeah. So for
Reversible.
reversible, what formula we got? T V to the power gamma minus 1 is constant. We know this formula, right? Now, what
Yes,
is given in our question? T is directly proportional to V to the power minus half. How can we write like this? T is equivalent to K into V to the power minus half. So, T into V to the power half is equivalent to K. And we know T V to the power gamma minus 1 is constant. Now, if we compare both these equations, we get gamma minus 1 is equivalent to half. So what will be gamma? 1 plus half. That is 3 by 2. Answer is 3 by 2. Okay? Clear?
Yes, ma'am.
Okay. Now, moving to sum number 2. Calculate the final temperature of a monoatomic ideal gas. That is expanded reversibly and adiabatically from 2 liter to 16 liter at 300 Kelvin. How to solve this? See what it is said. Final temperature of a monoatomic ideal gas, which is expanded reversibly and adiabatically. Right? So, T v to the power gamma minus 1 is constant. Okay? So, what we can write? T1 v1 to the power gamma minus 1 is equivalent to T2 v2 to the power gamma minus 1. And monoatomic gas. What is the value for gamma for monoatomic gas? 5 by 3. In yesterday's class, we did it. Right. What is T1? 300. What is V1?
2
2.
liter.
What is this? 5 by 3 minus 1. What is T2? We don't know. We have to calculate. What is V2?
16.
Again, 5 by 3 minus 1. So 300 into, what will be this? 2
By 3.
to the power 2 by 2
Minus 1.
is equivalent to T2 16 to the power 2 by 3. So what will be this? T2? T2 will be 300 into 2 to the power 2 by 3 by 16 to the power 2 by 3. I am doing the calculation here. So it is 300 into 2 by 16 to the power 2 by 3. So it will be 300 into 1 by 8 to the power 2 by 3 is equivalent to 300 into 1 by 2 to the power 3 to the power 2 by 3. This 3 cancels out. So 300 into 1 by 2 to the power 2. So it is 300 by 4. You will get the answer in 75 Kelvin. Is this sum clear? Sum, the calculation and everything. Is this clear?
Yes,
Just
ma'am.
check and let me know. Is this clear or not?
Yes, ma'am, it's clear.
Does anyone have any doubt regarding this? See, so from this question, what important derivation we can derive? See, temperature was 300 Kelvin. Now the temperature is 75 Kelvin. What can I conclude? Temperature will decrease in adiabatic expansion. The process can be reversible or irreversible. Is this part clear? The whole sum? Huh?
Yes, ma'am.
Okay. So are you finding it interesting to do these sums, or no, it's just like we have to do, so we are solving. Okay, let's do this sum. 1 mole of an ideal gas it 5R by 2 at 300 Kelvin and 5 atm. Is expanded adiabatically to a final pressure of 2 atm against a constant pressure. See, constant pressure of 2 atm. Find final temperature. What it is said? Ideal gas, 1 mole. This is given expanded adiabatically. Constant pressure means reversible. Okay. For reversible, what is the final formula I told you for reversible to calculate?
P raised to 1 minus
For
gamma.
reversible. Okay. Sorry. I made a mistake. Constant pressure, it is irreversible, right? So for irreversible, what is the formula, final formula? I told you, C5 to calculate the final temperature, this. So we will use this formula first to calculate the final temperature. Once the final temperature is calculated, then we will calculate the work done. So N CVM delta T is equivalent to minus P of external nRT2 by P2 minus nRT1 by P1. What is N? 1. CVM 5R by 2. What is delta T? Given? No. T2 minus of 300. What is the P external against I told you to consider this final pressure as the P external. So 2. Okay. What is N? 1. What is R? R keep R as R only. T2 as T2 and final pressure is 2. Minus 1 into R into 300 divided by 5. So, can you do this? Do this and let me know. So what will be it? 5R/2 into T2 minus of 300 is equal to -2. If I take R common, T2/2 minus 300/5, 60. So it is 5T2/2 minus 5 into 300/2. 5 into 300/2. It is, see, RR gets cancelled. Okay. So it's this two will get cancelled. T2 minus of minus plus of 120. Okay. So what will be our T2? It will be 72. If I take this here, 72/2 minus 750. So it will be coming as 150. So it will 750 is equivalent to 120. So T2 will be what? 870 into 2 by 7 or something in Kelvin. So is this part clear how to calculate the final temperature? Now in this process, if they have asked you to calculate the work done, what will you do? This part is calculated. Then for work done, use this formula. So work done is equal to N CVM delta T. CVM is given, N is 1 mole. It is 1 into 5R/2 into delta T, you will get something minus 300. Okay, so this is how you will be calculating the work done. So is this sum clear? Is this sum clear?
Yes,
Yes
ma'am.
or no? Good, good. Okay. Now, just I will
Ma'am,
say about the polytropic class process and
ma'am,
yeah.
can you tell me why? How can we get work done?
How can he?
Did I work on, ma'am?
I told you that formula, right? Wait. So it was an irreversible process. I told you. For irreversible process, we are using this formula to calculate the final temperature or the initial temperature, whatever is mixing. Then after calculating this, for calculating work done, we will use this formula. Okay.
Okay, ma'am.
Okay, that's what I have done here. 5R/2, okay. There is no space to write. So I couldn't write it there. So once this final is calculated, suppose this is X. So work is N CVM delta T. What is N? N is 1. See, it is given as 1. CV is 5R/2. And delta T is X, whatever you will get here, minus of 300. Okay, that is how you calculate the work done for a irreversible adiabatic process. Okay. Okay, is this part clear?
Yes, ma'am.
Okay. So I will just start with the polytropic process and then I will leave. Then I will do the extra class on Sunday. What is polytropic process? For polytropic process, P v to the power n is equivalent to constant. Okay. What does this mean? If n is equivalent to 0, then P is constant. P is constant mean isobaric process. Again, if n is equivalent to 1, then PV gets constant. PV is constant for isothermal process. Now, if N is equivalent to gamma, then PV to the power gamma is constant. What is this process? Today only we learned it is adiabatic process. Okay. Up to this, is this part clear? So from this, how can we calculate work done? So see, from this formula. Where is this formula? This. Work done delta PV by gamma minus 1. Okay. Here also the formula will be exactly same. Work done will be delta into PV divided by gamma minus 1. It was their formula for reversible process, but here instead of reversible, we are calculating work done for polytropic process. So it will be N minus 1. Or we can write like NR delta T divided by N minus of 1. Okay, but remember, N cannot be 1. Okay, see if you put N is equal to gamma, PV by gamma minus 1, that is the work done for reversible adiabatic process. If you put N is equal to 0, it will be coming as minus 1. That is the formula for isobaric process. If you put N is equal to 1, this will come as infinity. And remember, for isothermal process, in last week classes, we have learned that for isothermal process, in work done formula, we get log, right? In the formula, remember, there was log, right? So this N cannot be 1. This formula cannot be used to calculate the work done for isothermal process. Is this part clear? Is
Yes,
this
ma'am.
part clear?
Yes, ma'am.
Okay, wait. Then before you leave, what is molar heat capacity? This is a JEE advanced topic. Molar heat capacity. What we get? Delta U is equivalent to Q plus W. Okay. Now, this is not an adiabatic process. I am telling this for polytropic process. So you can't put Q is equal to 0. In yesterday's class, we have derived delta U is N CV delta T. What is Q? NC delta T plus W. Yesterday from the molar heat capacity. Okay, this is what I have got from molar heat capacity. Okay, now, so what can we write it like this? If I NC delta T and work done, this work done can be just now what we have written, work done. NR delta T by N minus 1. NR delta T by N minus 1. Okay. Now, if we divide it by NCV delta T divided by N delta T. NC delta T by N delta T. And NR delta T divided by N minus 1 into N delta T. I am dividing both sides by N delta T. See, lot of things will get cancelled out. So what we are left with, CV is equal to C plus R by N minus 1. So this is a very important formula. CV is equals to C plus R by N minus 1. Okay. And CV is R by gamma minus 1. From where did I get this? Today's class only we have done. Where is that? From here, we have got that CV is equal to 1 by R by N minus 1, gamma minus 1. Okay. So up to this, is this part clear? Up to this, whatever I have written, is this part clear? Everyone, up to this, is this part clear? Just say, then I will just put an end to this class.
Yes, ma'am.
Okay, so I will be sending you this PDF. Try to learn, try to see try to go through what we have done so far. Okay, in case you have any doubt, you can reach out to me. I guess the whole part, whatever we have done in thermodynamics till now, is clear to everyone. Is it clear to everyone? Yes, no, say something. Start
Yes.
revising. Start revising whatever I have made you do in the class, and once you revise, you will be pro in the sum. There is another small topic called the free expansion. So free expansion, let's do it in the next class only. This is a very small topic, just one line I have to say. Then in Sunday's class, we will be solving sums. Okay. Extra class, we will be solving only the sums. Okay. Okay then. So this was from my end.
Thank you, ma'am. Students, join the next session.